Thank you, everybody, and good afternoon. So, first of all, I would like to thank all of you for your presence, and I would like to thank the organizers, especially Wagner. Wagner called me a few months ago and invited me to the seminar. So, thank you, Wagner. It was very kind of you. I would also would like to thank Roberto for his support and his warm welcome. And I'll have a special word for Saide, because I know she spent a lot of time and a lot of energy these last months to prepare this, and it's kind of a great achievement for her, so congratulations, Saide. Right now, I would like to make a short introduction, because yesterday we talked about black sheep, and unfortunately I'm one of them. I'm a civil engineer, and when Wagner asked me to talk about urban ports and the relationships between hydraulic structures and town planning, as an engineer, I thought that the best way to explain our work and the concerns I want to develop today was to start with explaining you how we work inside our study office and the close relation that we have with architects and town planners. So I will first show you a few slides of our study office and our past realizations as an example of what we do. And then I will come directly to the topics of the day. That means the hydraulic works. And also, as an introduction, I would like to say that technical aspects and architectural and town planning aspects are very close to each other, are very linked. And it's always the starting point that might be different, but at the end, everybody has to come to the same point and to gather. And it's really the red line of my speech today. It's talking about technique, but not as a purpose in itself. Technique only helps to achieve other aims that are connected to people and water and well-being along the water. So we come from Belgium, so I think we've already spoken a bit about this country these last days. We have two offices, one in Brussels and one in Liège. This is our team, so we're about 180 persons, engineers, architects, and technicians. This is important to mention that we have a small group of architects inside our team, and this is due to the fact that our founder, René Grèche, had both diplomas, as well engineer as well as architect, and he always tried to give this idea in all our projects that we had to work together, to collaborate from the very beginning of the studies. And this is the reason why we have an internal architectural department that helps all the engineer, all the departments to give this sensitivity inside the project. So I will go quite quickly through a series of projects that we made during the last decades, such as bowstrings here over Albert Canal. Another one, which is a bit different, but we always strive for simplicity and for logical integration. This one was a cable-stayed bridge which was built on the side of the river and then was turned in its final position. And I show you this example because it's one of well, how can I say, it's one of the specificity of our studies is that we always try to find clever ways to build the structures in a safer way, quicker, and also to improve the quality of the final elements, such as concrete parts. This is another realization in Tournai along the Scheldt. And for this realization, we've worked with French town planner Nicolas Michelin, because this is another fact. As a study office, mainly composed by engineers, we are, I would say, daily working with town planners, urban landscapers, architects from other offices. So this is really rich, and this is important for the project to mix all competencies, all knowledge from town planners and engineers. This is another example that has nothing to do with waterways, but I wanted to show you because it was quite funny. That pylon was built completely on the ground, and it was then rotated in its vertical position. It also had a lot of advantages for safety reasons and for the rapidity of the construction. This is another bridge which I'm really proud of. It's called Eau Rouge, and it crosses a valley which is a very sensitive environmental area, and so we had to do this huge arch with a simplest structure possible. Those are high-speed trails, high-speed train bridges. This one studied with French architect, and this one was designed by Santiago Calatrava in Orléans, and we made the stability studies for this complicated bridge. This is another example. This one is ours, so sometimes we do the architecture ourselves, and this is the case for this bridge in Wandre. This one was the last bridge of René Grège. A few months before his death, it was inaugurated. It's a fruit bridge in Maastricht, in the Netherlands, with a single arch, and it connects a new housing area and the park on the opposite side of the Meuse. It's very much appreciated by the citizens and the bikers. This is another example of what we can study. Again, with architect Santiago Calatrava. This is the railway station in Liège, where we had to do all the stability studies of this complicated structure, but really fantastic station well, I mean, I live in Liège, and this is really something that enhances the quality of a whole city. This is another example of structures that we are to study. This is a tower in Qatar, at Doha. This one was also a great achievement. It's the Millau Viaduct in the south of France, designed by architect Norman Foster from England, for which we did all the stability studies. As other field of activity, we are also specialized in airport infrastructures. And this is another example of bridge that we designed ourselves. It's at La Réunion, so in the Indian Ocean, where there are lots of huge valleys, as this one, where lava runs through to the ocean. So it gives the occasion to design quite interesting bridges. This is another structure that we had the opportunity to study. It was designed by architect Franck Guéry, and we had the responsibility of the stability of all the shells. Those are structures combining wood and steel. All the shells are different, and the result is really spectacular. This one is the last bridge we've studied in an international consortium, and it's in Istanbul. It's the third cross of the Bosphorus, so it's a bridge of more than 1.4 kilometer span, and it combines two techniques, a technique of cable stay bridge and a technique of suspension bridge, which is quite new. This is the financial tower in Liège. We've just finished with architect Jaspers from Brussels. And this will connect us to the waterways, because these new locks in Arpsin have just been, well, the study has just been finished. The project is in tender phase and will start probably next summer. It's a project. It's a very multicultural, multidisciplinary project. Sorry, with two locks, with a footpath, new buildings, some landscaping with a path for the fish, a fish passage to help the fish to cross the 5-meter difference of levels between the two water levels, and it also includes some rail works. So this is kind of the kind of project that we appreciate because they mix up a lot of different aspects. And to end up, I'll show you just a picture of our office during winter. So it's opened so that everybody can work and talk with everybody. And it's in the forest so that we keep in a quiet atmosphere to think and to be as efficient as possible. So I go on with the topics of the day. This is the program, the schedule of my presentation. I'll start with a general introduction, 2 examples that were not studied by our office, but that for me are quite representative of what I want to tell you today, and I'll end up with three cases, 3 structures that we studied ourselves. So first of all, I start with a picture of the port of Antwerp. We've already spoken a lot of this huge port yesterday. About more than 8 million containers a year. It happens in all the marine harbors throughout the world. They are getting bigger and bigger, and they accept larger boats every day. That means that those boats are discharged very quickly, and there is a need for those boats to get rid of those containers as soon as possible because of a lack of a place to stock all of this. There is also a steadily growing ask for quick delivery, so everybody wants to get rid of those containers as soon as possible. That means that you have to build huge locks. This one is the Kielrecht Locht in Antwerp, known as, maybe Grit will correct me, but known as the largest lock over the world. Again, these locks help the large boats I've just shown you to get inside the port. So slightly you see where I want to go to. Those limits are always pushed a little bit further. That means that if you come with a graded boat inside the harbor over the first locks, as soon as you're over there, technically you're in the inland navigation. And accepting such boats in inland navigations requires that all the infrastructure that is behind this point needs to be improved and needs to be enlarged. This is an example of ships that are navigating through Canal Albert, so coming from Anvers and going upstream. These are 2 other examples of boats arriving in Liège, in this case, with containers or with cold stuff. And as you can see, those boats are, of course, also getting bigger and bigger. So we have 2 questions with this, and I've written them down here just to help us think about what is the future of the former urban ports, because it has become an evidence throughout at least Europe, for what I know, that the old city ports that were located downtown and that mainly were responsible for the growth of the city, they were part of the beginning of the city. Well, those ports are certainly too short, too narrow to be able to deal with such huge boats and such number of boats. And the second question is how to integrate the new harbor zones inside rural sites, because of course, every city has decided to build their new harbor areas outside the cities, just outside the limits of the cities. So you have two questions inside one problem. I don't pretend to give a general answer to this, of course, but this will lead the few examples that I will show you just now. I wanted to show you those kind of pictures because it's I will say it's another question, but I wanted to mention though, when you go up in the hinterland, you are subject to cross those kind of landscapes. So the question is also to protect these landscapes. Besides the fact of building a harbor or not, the boats are crossing those landscapes. There are some banks that are very fragile. There are all ecosystems that have to be protected, even against the effect of navigation. Those kinds of cliffs are also met along channels. So, to deal with these questions, I will have a first example, which is the one of the port of Brussels. Here you see a general map of Brussels, and this red line figures what is now called the perimeter of the Plan Canal. So you must know that through Brussels runs a small river which is called the Seine, not the Seine like in Paris. It's nearly the same, but it's Seine with two N. And it used to be a very little river that has been transformed into a channel. So the boats can ship through the center of Brussels through the channel. And it has been one of the elements, one of the major factor of the economic development of the town, mainly for cement fabrication. So this canal, all the portuary zones that are located next to it were very important for the growth of the city. And I was talking to you about the Plan Canal because Brussels is subject to the same prospects I was just talking about. The boats are too big, they don't come inside the city anymore, and besides that there is a certain reducing of, how can I say, heavy industry inside the city. So the surface that is here in this red line is about 700 acres that the city wants to reorganize following three main goals. Keep the economic activity inside the city. There is still a certain activity with the distribution of cars, for example, throughout Europe. They want to hold it. They have to create housings as an answer to the demographical boom. So they expect about 7% over the next 10 years, which makes a lot of people to host. And improve the public spaces. This is of course something that we have already talked about. Everywhere there is a river inside the city. People want to be there. That's the place they want to be. And as I told you, I live in Liège, and it's also the case. Every time there is a little strip of surface that is freed along the river, all the citizens directly go there. So it's an answer to the lack of private gardens, of public spaces. So these spaces are very important for the urban development. So they wanted to achieve this third goal as well. This is what can I say? We've got different kind of atmospheres along the canal in Brussels. Here you are in an industrial area, which is linked to cement, as I told you earlier, and you can see that the surroundings are mainly devoted to industrial activities. This is another point in the city, still the channel, and you see that it's very more a housing zone. There are inhabited neighborhoods. So the answer that the plan canal wants to give is different from one point to another. I will just show you one example. Is the old quai des matériaux, so-called materials quay, which is now subject to a transformation. This is a simulation of a project of MSA, which is a Brussels architect company, and this will be realized over the next year. So this is an example of the reappropriation of public spaces along the channel. I will talk about the example of Copenhagen, which is very interesting as well. So Copenhagen, this is a general map. The city of Copenhagen is located in here. Those are all channels that are now not used anymore. This is the main channel that used to drain all the navigation through the city. And this is the whole harbor zone. So here with the arrow you see those old docks. Of course, with the same reasons I told before, they had to move with their port, and they did it outside the city, as it looked logical that all marine boats could easier moor over there. And the question was, of course, what are we going to do with those old locks? And they had very interesting answers. So this is the kind of landscape you can have in the new harbor, which suits very few with downtown surroundings. So what have they done? Such kind of things. I think there's a problem with the picture. Sorry, I don't think it's okay. Right, they have modified their old docks. All the buildings that you see there are old warehouses where you can still find the old hooks and the old structures to hang the goods that were discharged from the boats mooring along these walls. And they have changed it, in this case, into housings. In this case, this was the oldest dock at Copenhagen. It's a postal card view nearly. It's called Nyhavn. It was called so New York at this time, but it's not anymore that new. But it's now devoted for tourism and tourism boats. This is another dock that was transformed into housings and bathing area. We are closely connected to the sea, as you saw on the map, and people are diving into the well, it's not the sea, it's the channel, but it's closely connected to. And you see all those wooden equipments to really give the dock back to the citizens. This is something really important. This is another example of an old dock. This one has been earth-filled. You see the old buildings in here. These are offices building. They also have integrated museums and public buildings all around those docks with those public spaces that have been completely renewed, that are very welcoming. An aerial view gives you another example of what they've done with their channel, which was finally too wide. Because it's funny to say, but starting from something too small, you finally come to something too wide. So they gained some touristical surface upon the river, thanks to Belgian architect Julia de Smit, to offer those kind of structures. And it has combined to all the other zones that I showed you just before. It has really given a second life to the river and to all its inhabitants. Going along the river by bike on both banks is really something fascinating to do. So, having these examples in mind, I will now come to a more technical part of my exposé with 3 different cases. First of all, the Port of Liège. Second, Nanny Lab Complex. And third, Saar Canal Bridge. I've chosen those 3 examples because it's a kind of trilogy of what you need to improve an internal waterway due to the increase of the traffic. First, you need ports, you need locks, and you need improved waterways. So that's a bit of a mix of what we have implemented in this prospect. So first, about the city itself, I just wanted to tell you that Liège has always been a steel industry town where there was a lot of coal. I mean, in the past century, there was a lot of coal around the city. So there's always been a tradition of steel making in Liège, as you can see on these other pictures. Well, most of these industries are now closed because it's the rule in Europe. You don't get the chance to make your own steel anymore. It's not competitive. But it's one of the reasons of the growth of the port of Liège, the fact that we had steel to sell. So you've already seen similar pictures, but I just wanted to remind you that Liège is located at a very interesting position in the European market. So 60% of the European purchasing power is located within a radius of 500 kilometers, which is not much, and 56 million consumers within a radius of 250 kilometers. So it's very important for a city like Liège, which is not located along the coast, to have close connections to different transport networks. So the water, the rail, the road must be efficient to reach those different markets. Another aspect that is more linked to waterways is the connection with Antwerp and Rotterdam. It takes only 14 hours to reach Antwerp and 12 hours more to go to Rotterdam. You've seen the huge amount of goods that have to be transferred from these ports. It's very important to have close connections with these huge infrastructures. Other connections, as I told you, are also achieved thanks to other ways. So Antwerp is only 130 kilometers by boat, Brussels 100 kilometers by road or rail, Cologne 120, also road or rail, Paris 360, Maastricht 30 kilometers by waterway, and Aachen, so in Deutschland, 60 kilometers. About the capacities of the Port of Liège at this time, in 2015, the waterway traffic was almost 15 million tons, sorry, and water railroad the total traffic was 20 million tons, and we had about 40,000 containers. The important number is this one, plus 27%. So this is something in a very fast increase, and this is the reason why we need to extend the port. Actually, there are 3 multimodal platforms in Liège. Liège Container Terminal, which you see here on the picture, Europort's Inland Terminal, and DP World, so the new Trilogy Port, which I will talk about. As another example, this is just a Google view, but about what I told you, this is Liège downtown, and these are the 3 points I've just talked about. This is Renery, this is Europort, and this is Trilogy Port. So we don't escape the same rule as all the other cities. We have to push our harbors outside. What does the new platform offer? 3 access to the sea, Antwerp, Rotterdam, and Zeebrugge. 3 transport modes, water, railroad, and 3 cross-border markets. And it might, at long term, multiply by 5 the number of containers that can be held each year. This is the main organization of the platform. I start with a bit of logistics, and I'll come back just afterwards to the concept of the platform itself. So here is the canal, here is the container terminal, and here are all the portuary zones with the logistics hall. Here is the green belt that has been achieved to protect the village that is situated next to it. I had just a small funny story to tell you. The first hall has been built. It's been owned by Walter de Pau, WDP, but the exploitation has been conceded to a French group, which is Tempo One, which distributes all the products of the Brazilian firm Aspargatas in Europe. That includes the Havaianas. So maybe Liège is a bit connected to Sao Paulo thanks to this way. Another aspect which is very important is that you don't build such infrastructure on your own. It's important to be connected in an industrial network. And this is the case thanks to the relation with the Port of Antwerp and the SPI, which is a local activating partner. And now the first containers have arrived on the platform, so the new terminal is launched. So I come back a bit backwards. Before building this, what was the problem? Not the problem. What was the question? We are located. This is the view of the Meuse, just next to the future platform. You see, this is a quiet area. We have the side of the valley on the right bank. We have a village on the left bank. And this is the kind of environment surroundings that you have to deal with when starting the study of such a huge platform. This is an aerial view. Here is the canal where all the navigation is located. And here is the Meuse, which I show you just at the moment. You see that there are villages at the north part as well as the southern part. So the new platform has to be located here in an interesting place if you see it on the economical point of view, but also a difficult place because of the rural zone. That was one of my questions of the beginning. So a few datas. The total surface is 120 acres, and it includes 25 acres for environmental improvement and 15 for access infrastructures. So that means that one third of the whole project is devoted to non-directly productive surfaces. This is important. This is one of the, well, I won't say this is a rule because it would be a bit, it would be a nasty view. It's also a purpose. We don't want to implement such huge concrete surface without spending time and also surface for environmental aspects. But we must admit that it has also become a kind of necessity, certainly in zones that are quite densely inhabited. So in the project we have constructed here a railroad, a road network, including a bridge over the highway and the Meuse, and a series of water zones that are devoted to environmental developments as well as cycling tracks. This is a future view of the complex when it's finished with its series of halls, the full terminal, and some gas surfaces. What is important to see is this green belt, which is half made out of water plants and half made of forest and footpaths. This is another view after completed area. So over a few years when all the structures will be built. Here are a few pictures of the situation today. This is the first hall that's been built. This is the first third of the terminal that is also already in function. And this is the green zone that is starting to grow because trees need a bit of time. This is the new bridge that we have designed to cross the river and to give a direct access to the zone, because this was also one of the aim, not to disturb the life in the local villages. So this bridge was really dedicated to give a direct access from the highway to the industrial area. This is another view of this new structure that we wanted as light as possible, and that is connected to a green axe that I will just show you. This one. We worked with our landscapers to. This is an old existing dock, and we continued this line up to the River Meuse, which is 7 meters lower, with a sort of stairs, a series of water plants devoted to working zones, fishermen, and of course natural development. And this axe was kept for the access road, as you can see on this picture. So we were talking this morning about a peaceful approach. That's what we always try to do in this kind of project. Things must look simple, because that's the way they will be accepted, and that's the way people will think that things have always existed like this. So it's no surprise, it's just the way you wanted it to be. It's a kind of peaceful approach. I go on with Liège because now that we made a series of portuary zones outside of the city, what happens downtown? This is an old picture from the beginning of the last century, and another one about the same period, so 100 years ago. At Liège downtown, there always used to be a harbor. This is a commercial boat with transporting goods. This is another one shipping through a lock. So there is a waterway tradition downtown itself, but things have changed, and of course when boats are not supposed to stop anymore inside of the cities, you have this waterway that becomes too large, and when you are looking for some place to develop, to build new housings, you start filling these extra wideness with earth, and when it's filled up, you start building highways. This is the way it happened at too many places in Belgium for sure, and probably in other countries as well. So this is an example of what happened during the years 60s, so 50 years ago. We built those highways just along the river, which was such an interesting place. And you can believe me, if you are just walking and you want to reach the bank of the river, you risk your life. So the purpose was to change it, to stop those urban highways which have no sense. So we made this, which was achieved thanks to the collaboration of French town planner Michel Corajou. So this was a complete renewal of these old areas. They used to be ports. That's important to say. It was a portuary zone that has been earth-filled and now is given again to the citizens. So we have kept a boulevard which has nothing to do with the highways. You've got crossroads, you've got red lights, a series of pedestrian ways, and moreover, we have given the keys back to the people. We have also built this new footbridge that connects this zone. You'll see on the next picture, this is connected to the station, and this is a park. So there was a real need to connect those zones, and it was really asked by the citizens as well. This is another view of the project that has been achieved last year. So this is the exit of a tunnel. We kept a small tunnel that goes this way and that helps the cars to get out of the city when they are in this direction. And the rest is really become peaceful again and is welcoming for all the different type of users. And this footbridge gives a connection with the right bank. This is another view of the tower I showed you earlier. This is the new footbridge that has been designed for all kinds of users. So people with bikes, people that have mobility problems, and most of all, it's also a place where you can rest. You're not obliged to walk through it. You can lean on, you can sit on the main truss. This is another view from the right side of the river. This one inside the park. So the connection of a footbridge with its abutments is something really important, because the footbridge will be used if the people can reach it. So we made different ways of reaching the footbridge from different places, park or on the right side, on the left side, sorry, of the river. This is another example. I think it's a school. It's a class of a school going to an event and biking through the footway. Besides this footbridge, I told you there is this new area along the Meuse, which has been directly, how can I say, has become a real friend for all the citizens. Now I will talk about another project, which is the Nanny Lab Complex, and this is a more technical work, but you see that the achievement keeps the same. That means this is an industrial infrastructure dedicated to high tonnage boats, up to 9,000 tons a boat. So it is huge. It is really big, and the goal of the design is to make it human. So to let it keep human geometry, a human aspect. So this was the goal. This is a simulation before the works. We had two old locks from the years 1930, this third lock from the years 1960, and the new lock to be built here. Just a few facts about the owner, which is public administration, Sofico, and Voies Hydrauliques de Liège. Main contractor was SpaceX, and the cost is about 140 million euros, thanks to the support of the European community. So just another few dimensions. The lock is 225 meter long, 25 meter wide. The head is 14 meter. It is managed by butterfly valves and longitudinal culverts. This is the location. You see the border between Belgium and the Netherlands. You see these three old locks, and the new one had to be built upon the border, which led to a series of discussion about financing and compensation zones. You also see on these pictures that we are located in a very green area. It's a protected zone for fish and for a lot of kind of birds. This hill is also very symbolic, with a very particular ecosystem that had to be protected. So our first idea was to have a simple geometry. As I told you, there are 4 structures that have been built at different periods, so with different methods and different answers. We wanted to reunify the whole site to make it as simple as possible. That's the way we started to think of making a block which would involve old material areas. This is a zone that is used for technical purposes. The third block, the central pier, which I will tell you later, is equipped with a hydroelectric and pumping station. The new lock, and here is also a tunnel, because cars have to reach the downwards zone if necessary. So we had a full structure that we wanted to group so that we could have a simple answer. So this is all, again, a simulation of this block, and the new bridge crossing the whole site has been detached a bit at the downstream zone so that it could simplify the lecture of this lock system. So the lock itself, I won't be too long about the technical aspects, but you must know that there is a lot of technique of, let me say, science inside the structure, such as this is a transversal cross-section of the structure with the central zone where the boats come up and down, and the lateral culverts that help to fill and empty the lock. And this structure lays upon different layers of ground that are particularly sensitive to underground water flows. So we had to build those diaphragm walls all around the structure to ensure that we have a long-term stability of the structure. This is kind of things that you don't see, of course, when you come and visit now. Another aspect I wanted to talk about is, for example, the upstream door. You see these old structures that had been built previously for the 3 first locks. This is the new structure. I was talking about simplicity. This was our goal in this case. This is a photo of the door that lies under the water, just of course during construction stages, so before filling the lock. And this is just an example of the calculations that we made for the design of this structure. All the equipment that is needed to steer the door is located into a very minimalist block, and everything is, nearly everything is inside the ground, so that you have something that keeps at human size. I have a small animation, I hope it will work. I will try to explain you without the video, but what you must know is that this structure is just put inside a small concrete structure which has a steel grid so that it deserves natural light. And these jacks activate a kind of small car, let's say, which is on its rail, and which itself activates these bars that are connected to the door, so that everything moves under the concrete surface. I'm sorry for the video. This is another view of the downstream door. And what is interesting with this is the huge size. You see here this elevator with the guy working on this. This is about 20 meters high. So those are huge structures, partly under water level, but they have to be built as simple as possible to be, again, in the same simplicity aim. I told you about this structure. This is located in the central pier, and it's also in the context of a sustainable work. As soon as you build such big locks, you have a great water consumption, and by dry periods, you might have some problems in the river because of the consumption. So we have built in the middle, in the central pier, a pumping station in this situation, so the water comes back to balance the weekly consumption of the whole site, so I mean the 4 locks working together. And in wet periods, then we have on the contrary, on the other hand, we have too much water, so we use the same infrastructure to produce electricity. That is, of course, an interesting sustainability aspect of the project. I told you about the bridge. Here again, we wanted to have something simple and sharp. We have a steel box girder and a concrete deck over it. Just a single pile at the angle, and this 90 degrees turn keeps very light. Another related work was the design of the new control building, which will take the lead on all the 4 locks. And of course, the development of environmental zones. This is a fishing zone for the reproduction of the fish, which has been digged out and which has been planted so that with different width of water you can welcome a large series of fishes from different types. Other related works, such as hydraulic studies that have been led with the collaboration of the University of Liège, were also important in this project, in this multidisciplinary project. I have now a series of pictures of the construction stage. You will see all the technique, all the technology that has been put inside to the finish, to the final stage. So this was a kind of war during the beginning of the works with the concrete plant. They've recycled the gravel that laid underneath the ground. They had those huge cranes and a lot of sheet pile works as well. So I go a bit faster. This is the casting of the deck of the bridge. This is those huge sheet pile zones with the concreting of the downstream pier. This is the construction of the bridge, and here you see the 4th lock being started. Still a 4th lock being reinforced and concreted. This is the view of the empty lock. Of course, you can see those 2 guys making an inspection. This is something very impressive because of about 22 meters height. This is another view from inside. And we often say that sometimes when you have to build a very, very big structure, such as a retaining wall, before building it, be sure that you really need it. In this case, it was needed, of course. We wanted to develop the navigation. But when you see those huge structures and you translate them in another environment, such as I told you, retaining wall, I know that there are many cases where, if you think about the topography, about the geometry of the work, sometimes you might even not build this wall. And it's something that we must keep in mind, and it's closely connected to what Frédéric said this morning, is that you don't have only to think about how to solve a problem. You must also think about, is the question right? And this is important. This is the final view of the lock that is now in service, that is used. You see the door I was talking about, which is really discrete. You see all these zones that have been replanted. There are footpaths. Of course, nature must take her time to grow and to develop, but mainly we try to give the complex a unity and a kind of peaceful context that it deserved, that it certainly deserved. And last of all, I will talk a little bit about Saar Canal Bridge. So what was the purpose? This is just a view of the existing zone. You have a highway in here. This is a speedway crossing the highway and going to the south. Here is an industrial zone that already existed and that was subject to development. And this is a village, the village of Oudin. And you can see here on the right side the extremity of the existing canal just before the construction of the bridge. And the purpose was to build a bridge for the canal in this direction. And this led to this construction. It's important to say that this is a valley, not a very deep valley, but a valley nevertheless that is where is a small river that is partly underground and partly on the surface. Of course, this bridge is 500 meters long. I will show you the dimension just afterwards. It was no way of earth filling the whole valley, of course, because of the river, because of the village, because of the road, and because of all the surroundings, all the views that we wanted to keep. So it was decided to build a canal bridge that you see here in a lateral view of about 500 meters long, of 33 meters wide, I mean the useful width, with a series of piles with a distance of 38 meters. So that means that you had a series of square shapes, or nearly square shapes. And if you know a bit about concrete design, calculating such huge plates of about 35 meters along each side is not something that easy, because the width is similar to the span. So we made a series of simulations before the works to show how this new bridge could be integrated into its environment. And you see, just as an introduction, the picture of the work that has been done, and it looked quite like the simulation, so it's reassuring. What are the specificities of the structures we've designed? The side walls are used as main structural girders. So that means that we don't have any longitudinal beams underneath the structure. It's the structure itself, the lateral walls that are used as beams. We give the structure a high hypostaticity degree, which will give it nearly no joint, dilatation joint, one at each extremity, but no intermediate joint, so improve the waterproofness. A limited number of supports, I told you only 38 meters between each pier, and a series of transversal beams, pre-stressed transversal beams. So this is the cross section. All the structure is fully in concrete. You have those transverse beams, precasted and pre-stressed transverse beams, and all the rest of the structure was cast on site. You see the lateral view. We imposed casting with wooden elements, small wooden strips, so that it would break the linearity of the structure and give it a rhythm. This rhythm is reinforced by those elements that are located in front of each pier and that reinforce the structure to help placing the supports. Why have you chosen for a trapezoidal shape? It has better hydraulic parameters than a rectangular shape. It's easy to understand because we have extra wideness where the boats don't chip, and that can help water to flow around the boat easier. So it widens a little bit the hydraulic surface. It gives a protection of the bearing elements. So this concrete plate helps protecting the bearing elements from a boat shock. And it provides a footway on the upper flange. So this is the cross-section that has been designed. Something important is that there is a lot of pre-stressing in those structures. Concrete is watertight if it's compressed. Whether you start having some traction, it's bad for waterproofness, it's bad for durability. So in this structure, we wanted that all the surface of the concrete that would be in contact with the water should be kept into compression. So there was transversal prestressing. This prestressing was organized in a sort of V-shape, as you can see on the upper view. There was also a longitudinal prestressing. You have two kinds of prestressing, a straight one, which was used during launching, and a wavy one that was used in service, and the wavy one goes this way. Just a picture to show you the complexity of the reinforcement and all the tubes that are placed to host the pre-stressing. This is another view of the casting of the structure, all with modular elements. We did some other actions to ensure the waterproofness of the concrete. We gave it an inner compacity by choosing the ratio between the different components of the concrete. We placed this post-stressing I've just talked about. We limited the number of joints. We added a waterproof adhesive sheet, and we imposed a special precast material to avoid air bubbles. So those were all the impositions that were given to the contractor before he started the works. And we also imposed a launching method. It has a better execution quality. Remember what I told at the start of my speech? I was talking about simplicity of construction, security for the workers, repetitivity and quickness of the construction. It's been offered by the method. And also we avoid traffic conflicts with the speedway running under the bridge. So this is a view of the start of the launching. You see all these piers that have been cast before the bridge comes over it. So the principle was this one. You had this steel nose that was used to help reaching the next pile every time. You had the first concrete elements, and the crane added the casting material. A new section of 12 meters was cast on side, and the whole structure was pushed upon the existing piers. This is a view of the construction. You see that the speedway keeps in service, and there is nobody walking in there. It's only it's only a forest of columns, but everybody walks at the backside. So this was another video, but I guess I might have the same problem as the previous one. Oh no, it seems to work. So let's have a look at the construction. This is the casting area. This is the steel nose. This is the first element. And when it's dry, it goes on. And we push the whole structure. At the end of the launching, it became a world record for the weight of the concrete structure to be launched, 65,000 tons. It speeds up a little bit, but you see how it has been done. The connection to the canal, then it's been filled in by water, and the first boats came through it. And we added some important surroundings, green surroundings. Here is a series of pictures of the realized work just after. This is one of the first boats crossing the bridge. And this is a series of pictures after the green improvements. These were closely connected to water because these water areas are inside the bed of the small river I was talking about, and they have become recreation and also environmental areas that are really appreciated. We have also created some biking path. To end up with this kind of structure, you see that the green horizons haven't been broken by the structure. Of course, there are roads, but there were already roads before, and we try to, again, not to push, but to lay the bridge on its surroundings, such as we had touched nothing. But in fact, under those piers are very heavy foundations with large boreholes and all the technique that I've been just explaining. This is another view. You see that the village keeps connected to the surroundings, the river, and these green areas without having a wall in front of it. So I will now come to my conclusion and just repeat the main facts. We face an expansion of inland navigation, which we're proud of, but it needs typical answers in the hinterland. We need larger inland ports, bigger locks, larger waterways. And with all of these aspects, we have to rearrange our historical city harbors. And I'm glad that this topic was also given by previous lecturers, as it concerns a lot of cities. So two distinct challenges. This is an example of a weir that we've just ended up. It's on a river called the Dander. It's in Belgium, and it's an automatic weir. So nobody works in there, but we need it to have a fully automatic structure with an equipment building. I think that we must think about simple solutions, about logical solutions. And so I would say that my wish is to promote strong, simple, undecorated and plain solutions, a respectful approach of the landscapes, and durability of the structures and the spaces might be found through such a peaceful approach. I thank you for your attention.